Hi, good morning. Today is 17th of September 22, and it had been a while since our last discussion. Our last discussion was about geophysical surveys and its technical aspects. Now, I had a good fortune of working in geotechnical vessels in North Sea and the Baltic. So, I would like to share my experiences on geotechnical vessels and the geotechnical survey. To put it in perspective, we have two types of preliminary surveys: geophysical and geotechnical. These surveys basically aid to determine potential engineering constraints and identify safety hazards by collecting information on the nature and mechanical properties of the seabed. While geophysical methods include mostly electronic system for data collection through seismic reflection, refraction, magnetic, electromagnetic, electrical resistivity and conductivity surveys, geotechnical surveys, on the other hand, have a more physical aspect to it that involve a combination of sampling, drilling, in-situ, and laboratory soil testing. So, what is a geotechnical ship? Basically, geotechnical ships are specialized vessels which have deep water drilling capabilities, which may go up to 3,000 meters. These are either 4-point mooring systems, jack-up rigs, or these are dynamically positioned vessels, which basically are vessels that have the ability to hold their position in a reasonable sea strait with the aid of various thrusters. Geotechnical vessels, apart from having a drilling system, also maintain on board soil testing laboratories. Basically, a geotechnical vessel conducts the fieldwork for geotechnical engineering, which is the study of the behavior of soil under the influence of loading factors and soil-water interactions. Apart from other things, this knowledge is basically applied to design foundations of wind turbines, oil and gas platforms, retaining walls, earth dams, and clay liners. This type of due diligence helps to see how the soil will respond to changes due to the proposed construction activity. These surveys are often a prerequisite for obtaining a permit for an oil and gas platform or a wind farm or any other construction project offshore. The field methods for geotechnical investigation constitute borehole drilling with disturbed or undisturbed soil sample. It mostly includes API or geobore drilling. Geobore drilling is rather an old, heavy-duty drilling where we require to investigate beyond the various bedrock layers below the mudline. To conclude, geotechnical drilling is a method of investigation of subsurface soils to provide a data for engineering design prior to a construction. Apart from age-old soil sampling, where we collect soil sample in the thin wall selfie tubes, electronic and technical methods are also prevalent and applied. These methods are basically used for verification of the soil samples we got from our drilling and for further elaboration of below the mudline features. These includes cone penetration test (CPT) and may also include pore water pressure measurements, which then become CPTU. The final geotechnical report typically presents factual and interpreted information which serves as the basic for a civil or structural design for a development of wind farm or a oil and gas field. When we talk of capabilities, we must also mention the limitations of geotechnical engineering. The solution of the theory of elasticity cannot be applied directly because the soil does not process a linear stress-strain relationship. The soil basically have three phases: soil, water, and the air. So the behavior of soil depends upon the relative proportion of these phases. To conclude, what geotechnical properties of soil are we basically looking at? We are looking at the grain size distribution of the soil, its plasticity, compressibility, shear strength, and these are all accessed by laboratory testing. We will elaborate on it more in our further discussions. I hope this one was interesting and a bit informative. Thank you for your audience. We'll see you around. Bye bye.